In this lesson, we're going to analyze the graphs of radical functions. So a radical function is in this form where n and p are both positive integers greater than 1 that have no common factors. So we're talking like cube root, fourth root, fifth root functions. So if we're looking at an even root function, remember that in the real number system, we cannot take the even root of a negative value. So this parent function's domain is restricted from 0 to infinity. Notice both the x and y intercept are at 0. This is a continuous function on its domain from 0 to infinity. There is no symmetry. It's always increasing. It has an absolute minimum here at the origin, and the limit for the end behavior only exists on the right. So the limit of f of x as x approaches infinity is also approaching positive infinity. It would increase. Whereas when we're looking at an odd root function, the domain and the range both go from negative to positive infinity. The parent function crosses at the origin. It's continuous on the entire domain. It does have symmetry about the origin. You could prove this algebraically by plugging in negative x and evaluating it. You should get negative f of x. The limit does exist on both the left and right. As it approaches negative infinity, as x approaches negative infinity, the limit approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. So in this first example, you need to describe the domain, range, intercepts, end behavior, continuity, and the intervals on which this graph is increasing or decreasing. Notice that this is a fourth root, so I know that my domain is going to be restricted. By looking at thinking about transformations and so forth, I know that this would be a fourth root that's stretched by a vertical factor of 2. It would be horizontally compressed by a factor of 1/5. Okay, so to really get a good sense of this, I'm going to put this in the graphing calculator and then I'm going to describe it. So the domain is from 0 to infinity. The range would also be from 0 to infinity. The x-intercept, I can see that both the x and y-intercept hits at the origin. There is no horizontal or vertical shifting to cause it to move. The end behavior does not exist on the left, but it does on the right. And it is continuous on the domain values of 0 to infinity. And this function is increasing 0 to infinity. It does not decrease. In the next example, we're looking at an odd radical. So this one is going to be continuous from negative infinity to positive infinity. There's no restriction on the domain or the range. Now, as far as the x-intercept, where it crosses the x-axis, we need to be able to solve algebraically a radical equation where we let y equal 0, and I'm going to show you that very shortly in our next video. For now, graphically, you can use the graphing calculator to see that this crosses at the point 4/3, 0. To get the y-intercept, all I need to do is find f of 0, which algebraically is approximately negative 0.38. The end behavior on the left approaches negative infinity, and the function is dropping, and on the right it's going up towards positive infinity. It is continuous on the entire domain interval from negative infinity to positive infinity, and it's increasing from left to right. This function does not decrease.